This video is about circles, including their equations and graphs. We'll start with some notes with the general form of a circle, and that form is x minus h in parentheses squared plus y minus k in parentheses squared equals r squared, where r stands for radius and the point h comma k is the center of the circle. In fact, that's all you need to define and graph a circle, a center and a radius that will whip all the way around that center. Let's look at a first example where we want to find an equation of the circle that satisfies the given conditions. Those conditions are that the center of this circle is the point -1 comma -4, and the radius is 8. Now, as you'll recall from the general form we just reviewed, that's all the information we need for the equation of this circle. And let's be careful to label. The center should be the point h comma k, which means they're telling us h is -1 and k is -4. So right away we can start constructing the equation of this circle. We know the general form is designated as x minus h all squared plus y minus k all squared equals r squared. And so if we're careful to plug in the numbers in the correct places, we'll be able to simplify this specific equation for the given circle. As we can see from our given conditions, h is -1. Now when you plug h as -1, that means you'll be writing x minus -1 squared. You might already be sensing the double negative that's about to occur here. We'll deal with that in a second. Let's keep going. So we have x minus -1, all in parentheses squared, plus the general form next has y minus k squared. Well, for us, that would be y minus -4 squared. Again, k is -4 in this particular example. And then that's all equal to r squared. Well, the radius is given as 8, so we'll write it as 8 squared in the equation. Now we'll go through and simplify once to end up with x plus 1 squared instead of the x minus -1. Continuing on, plus, and then we'll say y plus 4 squared instead of y minus -4. And then that will be equal to 8 squared, which is 64. So once all of those numbers are simplified, we were looking at the general form of this specific circle with center at -1, -4, and radius 8. One quick observation that you kind of saw happen in this example is that when you're looking at the final general form of a circle, what you see in the parentheses, like x plus 1, okay, you're looking at a +1. That's actually the opposite of the sign of the x coordinate of the center. And same thing with the y. You see y plus 4, but in the actual center coordinate, there's a -4. So just take note of that observation. It will help us when we go to graph these circles. Next, let's look at an example where we want to show that the equation represents a circle, and then find the center and the radius of the circle to do that. And then after that, we'll graph the circle. Now, the reason it might make sense to show that this equation actually does represent a circle is that it's not in the standard form we just reviewed. Let me read the equation given for example 2. It reads this: x squared plus y squared plus 1/2 x plus 2y plus 1/16 equals 0. So you'll recall pretty quickly that this does not match our general form. Let's bring that into play just to remember what it is. Generally, we have x minus h squared plus y minus k squared equals r squared. And as you can tell, this example does not match that. So to get it to match that, which is what we'd have to do, number 1, to verify that it's a circle, and number 2, to graph it, we're going to do what's called completing the square. Now, this is something we've already done earlier in our course, and so we'll review it, but now we're going to do it twice within the same problem. First, we want to get all the x's together and y's together. So I'm just going to rearrange these original terms and write them as x squared plus 1/2 x. Then I'm going to put plus blank, as we'll see the need for in a second. Okay, and then I'll move on to the y terms in order. I'll just say plus y squared plus 2y plus blank, and then equals, and I'm going to put this 1/16 that we had originally on the left side on the right side by subtracting it. Now we have to recall in the complete the square process what might need to be added in each of these blanks. You might recall that there's this b/2 squared value that has to be added in order to complete the square. And so for the x terms, the b value is 1/2. 1/2 over 2 is 1/4, squared is 1/16. So we want to add 1/16 for the third piece of the x trinomial. We want to do the same process for the y terms. For the y terms, the b value is 2. So b over 2 would be 1, squared is 1. So we're going to add 1 for the third term in the y trinomial. But adding two values to the left side of our equation means we should also add them to the right side of our equation. So since we added them on the left, I'm going to copy down the exact same blanks on the right side after the negative 1/16 we already had there. And I'm going to add 1/16 to make up for the 1/16 we added with the x terms. And then I'm going to also add 1 to make up for the 1 we added with the y terms. Now let's take a moment to rewrite what we have, but complete or factor the squares we've created in the process. We should end up with x plus 1/4 squared, summarizing the x trinomial we had at the previous step. Then we'll say plus, and then we should end up with y plus 1 squared, summarizing the y variable trinomial we just had. And that should all be equal to, well, on the right side now, you'll notice we had a negative 1/16 and a positive 1/16. Those would just cancel out, letting this be equal to 1. All right, well, given this, we have x plus 1/4 all squared plus y plus 1 all squared equals 1. This is standard form, which means we can pick out the center coordinates as h comma k. Now remember what we said previously, which is the h value is actually the opposite of what you're seeing in the equation. So our h value is going to be negative 1/4. And our k value is, again, the opposite of what you see. So we'll say minus 1. And then our radius, in the equation we see r squared. Well, we see 1, so that means the radius must be 1. Given this information, it's enough. We can go over to the graph and plot it. We'll do our best to plot the point negative 1/4 comma negative 1. Now the way these scales are written on this graph, every line represents a half a unit. And so negative 1/4 would actually be half of a unit, because 1 unit is 1/2 mark. So count carefully with any unit you're graphing, especially when they're fractional like this. Negative 1/4 comma negative 1 should show us right about there on the coordinate plane. Given these scales, which span all the way to the left of negative 2, all the way to the right of 2, and then down below from negative 2 to above positive 2, those scales indicate that half a mark to the left and then 2 marks down gives us the coordinate negative 1/4 comma negative 1. That's our center. And from there we want to go to a radius of 1, which is represented by 2 grid marks on our current scale. So if I go 2 grid marks to the right and 2 grid marks to the left from our center point, I can plot 2 more points. 2 grid marks up and then 2 grid marks down will give us 2 more points. Connecting these to the best of our ability to draw a circle, which is not easy, we will have a graph of this circle. Artistry is not the main goal, it's really about accuracy, so make sure points are plotted neatly and work is shown so that the center and radius correspond to the picture that we attempt to draw.